Hello everyone, good morning. Dear authors and invited guests, welcome to Technical Session 10D. Myself Prashi and this session would be moderated by me. On behalf of Global Knowledge Research Foundation and GR Scholastics LLP, it is my great pleasure to welcome you to the 10th International Conference on ICT for Sustainable Development, ICT4SD 2025, Goa, India. The 10th edition of this conference is being organized in a hybrid mode. The physical event is being held today in Goa, India, and the virtual event is being held through Zoom from 17th to 19th of July 2025. I hope you will enjoy the knowledgeable and interactive session through the day. In this session, we have 10 presentations. Each presenter will be given 10 minutes for the presentations and 2 minutes for the question and answers. On the ninth minute, I will be raising a gentle reminder. There's another request to all our participants that you all stay connected with us till the closing remarks. If you have any queries or updates, then you can write it to me in the chat box given down below. Just before we start our session, I would like to introduce you all to the chair for this session, Dr. Upesh Patel. Dr. Upesh Patel is working as Associate Professor and Head at Tirusat University, Gujarat, India. He is involved in teaching at UG, PG level. His area of interest for research include commercial antenna design, RF and microwave engineering, digital signal processing. He has published several research papers in international journals and conferences. He is a member of IEEE Antenna and Wave Propagation Society and Indian Society of Technical Education. We welcome you to the session, sir.
Thank you, madam. Good morning, everybody.
So, would you like to say a few words before we start our session today?
I will be covering the remark session at the last and concluding session. I think we should start with the presentation now.
For sure, sir. Thank you so much for being a part. Thank you.
Yeah.
So, I would like to present Sir S. Rahul presenting a paper on Dr. Bot, developing a chatbot for multilingual healthcare environments, a novel approach to breaking language barriers in healthcare communication. I request you to kindly take over with the presentation.
Thank you, Ms. Prachi.
Thank you, sir.
Yeah, so I hope my screen is visible.
Yes, sir, it is visible.
Yeah. So first of all, let me say with greetings. Good morning, everyone. My name is S. Rahul. Today I'm going to present Dr. Bot. This is a multilingual chatbot for healthcare environment. So our main focus is to break the language barriers between the medical terminologies and the people who lack the medical terminologies. So So the basic idea where it came is in our many of Indian people, like 80% of the Indian people are from rural areas and they don't have much knowledge about the medical terminologies. It's not only about India. 89% of Indian in UK is lacking the medical terminologies. 47% of Europe, US it is 36%. So overall globally it is 39% of people who is lacking the medical terminologies. Here where the problems arise. So if they get some blood test and the people who are willing to loot the people will say, like example, let's take leukocytosis. It's just an high WBC count. So the people in the doctors will loot the people by saying you have leukocytosis, which the people who is lacking the medical terminologies think that it would be a bigger problem and they are afraid and they spend lot of money. So here where becomes Dr. Bot. So what our doctor bot, so where it research this does is the people who will upload their medical reports into this bot and this will give a detailed information about the what the report contains, what are the severity of the reports like this. So in this we can achieve this by using BioBot and Google BioBot. So BioBot is an predefined medical bot which has 110 million medical parameters. So we can train that, like fine tune that according to our wish and make this possible. So Gemini Pro is used for the simplifying and language transactions, and it also contains offline functionalities. So the rural areas which is lacking the network can also use this, and the voice response. The people who are illiterate can also understand their medical report by just hearing in their own voice, like I mean, in their own languages, which they can select. So it has 97.8% accuracy in blood test predictions, and we have conducted a survey which has 92% of accuracy. To train this model, we have collected the lot of data by having a mutual agreement by the patient and the laboratories. We also trained this model by using medical encyclopedia, which gives the maximum accuracy of this model. So yeah, as I said, the user interface layer, the user will upload their PDF, and then the PDF will, and this BioBot model will extract the content of this report and gives a clear output. To ensure we have data protection layer also, which is mandatory for the users, and also we have followed all the ethical and medical laws to ensure it the safe and secure way of using the BioBot. So the technologies is BioBot, Random Forest, SVM. So BioBot is also, as I said, it's a biological bidirectional tool which reads the content in left to right and right to left. So it unlike all these chatbots we have, this will read the left to right and right, which increases the maximum output. Yeah, in real world we can use the critical gap. It prevents the misdiagnosis and misinformation for the clients. I mean people. Yeah, in future this can be weird as in wearable integration like watch and predictive analysis for the, and also we can implement this for the in hospital level like KIMS, Apollo, to ensure the doctor appointment based on the let's say the person who come with an cardiological problem. So this bot model will, this doctor bot will what do is it will take the features of the report. So what does the exactly the person is facing? If he's facing a cardiology problem, then it connect to the cardiology doctor to ensure the communication between them. Yeah. Thank you. That's it. So I'm open to questions. Anybody?
So have you developed this Doctor Boat application somewhere, or did
Yes,
you
we have,
just?
yes, we have developed it.
I would like to see any of the diagram or GUI, whatever you have developed,
So
or at least the
actually,
functionality how it is works. I mean, you already have explained something theoretical part, but I cannot see anything GUI based graphical representation of that. What you have actually developed.
yeah, sure. Actually, I have some video output of that model. So if you like to,
Uh,
I'll.
I think now this is not the right time, but I think you should include that into your presentation only, so people get more idea that what you have actually developed. Second question is, it is going to give you the facility for language translation.
Sorry, I didn't get the question, sir.
Whatever application you have made or the boat you have made, it is going to give you the facility of language translation, because each particular people are not comfortable with English only.
Yeah,
So
yeah. So that's our main goal, right? So everyone is not comfortable with English and their medical
so how
terminology.
how you have done this in your boat
We
part?
have we have used some translation APIs to translate that in their native languages, and we also implemented the voice output. So the people who can't read also can hear clearly.
Okay. Is there
because
any limitations of number of words in terms of translations and voice recognition capability?
not exactly. So what does it do is it's basically the it depends upon the report the person like the user will upload.
Okay. All right. Thank you.
Thank you so much.
Thank you so much for your presentation, sir. I would like to call upon our next presenter for this session. Our next presenter is Sir Prasad Chaudhary, presenting a paper on the title Improving Agriculture Productivity Through Data-Driven Pattern Classification and Machine Learning-Based Fertility Detection. I just request you to kindly take over with the presentation, please.
Yes, ma'am. Visible, ma'am?
Yes,
Am I
sir.
audible?
Yes, sir, you're audible and the screen is visible to us.
Okay. Good morning, sir. Good morning, all. I am Prasad, and I am going to represent the paper on the said topic that improving agricultural productivity through data-driven pattern classification and ML-based fertility detection. So, this is totally a try to help for the farmer class and how we can help farmers to get good yield in the form of many things means whichever whatever efforts they are going to use or whatever outcome they are expecting or whatever yield they are expecting. So talking about data driven pattern classification, it is the process of using machine learning algorithm to identify and classify that patterns with the data and without getting or without setting any predefined rules. Then talking about fertility detection, so it will involve accessing the nutrient content like pH, then some property or characteristics of the soil to be required for getting good suitable or which will be good for plants health. This will be outline. So current challenges what we are facing are like there is unpredictable climate changes, then soil
The slides
degradation.
are not moving. Please try to put into a full screen mode and change your slide. We can see
Slides are
only
not
title
okay,
slide
okay.
right now.
Just a minute. I will make it full screen. Just a minute, sir. Is it visible now, sir?
Yes, sir.
Yes, yes.
Okay. Okay, so current challenges we are facing, like unpredictable climate changes, then quality of the soil, and whatever infestations are there. So how to tackle with that? Then some inefficient farming practices are there, and how to upgrade or how to get the good outcome in the form of field, and what are the different need for innovation. So traditional methods we have to overcome, and how we can go with the use of AI, how we can go with use of IoT, so that considering some kind of automation or some kind of upgradation to time consuming method. So this is a try to overcome with the agricultural challenges. Now talking about the enhancement of the system, so as I said, we can integrate the system considering the multiple sensor under the heading of IoT. Then we can go with the soil analysis collection considering the whatever different agricultural data is there in the form of multiple photos, videos. Then if any kind of problems are there for crops, then we can get data considering the multiple photos. Then pre-processing module we can go with which is going to clean and extract the feature, and considering the feature extraction algorithm or considering the agricultural repository, we can enhance this system. So the purpose will be to go with the good health of the crop and to get the good fertility. Then this is something related with how the traditional methods are there, and how limitations are there, and considering our system how we can overcome with that. So if we are going to consider on this left hand side, so if we are going with soil testing, so these are like we can say traditional method, and what are the multiple limitations are there. So considering the list of the methods that are traditional soil testing, then visual crop inspection, then remote sensing, ML, then if we are going to use IoT system. So this will be list of the methods and what are limitations are there. So that are mentioned over here. So ultimate target is to, it should be user friendly, it should not in expensive, and it should be considering the setup. So we should get the good outcome in the form of crops. So these are some data driven approaches. So data collection importance is there. So how we are going to manage the crop, how we are going to maintain the health of the productivity and all. Then some data sets are referred, and we are also trying for our own data set by collecting the, as I said, by collecting the multiple images, collecting images from the farms area wise, location wise, locality wise, and we are working for this to highlight these challenges. So these are the challenges like consistency problem, so labeling efforts, environmental noise, and these are what we can go with. So IoT, AI, satellite sensors. Okay, so machine learning for pattern classification. So we have referred some classification algorithm, and currently we are out of this. Currently we are working for CNN, feature extraction. Also one of the steps for feature extraction we have referred, that is image analysis. And talking about feature extraction, that we have preferred principal component analysis algorithm. Then part of ML, that is deep learning, also used considering CNN algorithm. Then machine learning based fertility detection. So importance for sustainable farming is to get the good accuracy. So accurate fertility detection maximizes fertilizer use, and it is going to enhance related with the soil health and ensure sustainable land management. So all these about to get the good accuracy, and the ultimate purpose is to get good accuracy considering the input, considering the data availability on and all. So here the focus is on the parameter considering integration and accuracy. So some common methods are mentioned over here. So we are going to compare with SVM and CNN. Then talking about sustainable farming, it is method of food production that aims to meet current needs without compromising the ability of the or structure or quality of the soil. Then considering for the accuracy or to get these parameters, precision, recall, specificity, F1 score. So talking about precision is going to focus on accuracy of the positive prediction. Formula for precision is true positive divided by true positive plus false positive. Talking about recall, so recall is going to access the model's ability to find relevant instances. So formula for precision will be true positive divided by true positive plus false negative. Talking about F1 score, it is the harmonic mean of both. Both means precision and recall. And uh, data set that we have considered, that is for here we have considered normalized data set. So normalized data set is one where data has been transferred to fit within the specific range to get the to improve the model. This is about normalized augmented data set. So the one of the point or difference considering normalized and augmented data set is in augmented data set, it is going to refer the data that has been enhanced or modified to improvement its quality, diversity, and whatever usefulness is there. Then ultimate target is to show the good accuracy for whatever model we are going to use. Then these are some challenges, availability of the data set, and though if it is available, then what about quality, then computational constraint in real-time application, then generalization and scalability of ML model, And these are like some future scope, we can say, that advancement in AI or use of explainable AI, then to cross check whether there is potential for federated learning or edge computing. So as of now, we can say that about conclusion that agricultural productivity enhancement system provides a robust framework to get or to considering the good farming efficiency through the data-driven pattern classification and ML-based fertility detection, which is going to optimize the resource utilization, minimizing environmental impact. Okay, so these are references that we have referred. So,
Okay, so you have mentioned somewhere that you have taken up some real-time data.
yes, sir.
What type of result you received into that? I mean, is it satisfied result compared to?
No, sir. Currently, we can't say that we are on the good point that accuracy level is achieved. So it was one of the suggestion in one of the conference that whatever possibilities are there, means ready-made data set we can get or we are having. It was recommended that we want comparative analysis between both, means ready-made data set and whatever data set in the form of multiple images. So we have collected almost 2300 images from multiple location. So still augmentation means whenever we are going to refer our own data set, so augmentation part we need to consider, means if we are having a few number of images, so we have to augment that images in the form of data set. Augmentation means we can flip that image, we can turn that images in multiple angle, and ultimately that data set count or that count of that images that are supposed to be converted into multiple times in the count of into 3 into 5 like that. So we are remaining with augmentation, we are remaining with again comparative analysis, so that we can prove that own data set will work.
Okay, fine.
Thank you so much for your presentation, sir. Now I'd like to call upon our next presenter. Our next presenter is Ajit Patil, presenting a paper on the title A Hybrid Ensemble Approach for the Time Series Prediction in the Industrial IoT, the ERA model. I request you to kindly take over with your presentation, please.
Good morning, madam. Good morning, sir. I'm Ajit Patil, here to give a presentation on a hybrid assemble approach for time series prediction in industrial IoT, the ensemble regression algorithm, efficient ensemble regression algorithm. Today, I'm going to cover this much of topic in my presentation: introduction, objectives, dataset overview, performance metric, resource utilization, statistical performance, implementation details, and the last one is the conclusion. Today, in the introduction part, we will see Internet of Things. Today, we will see this industry is going rapidly. It's taking too much of market in the industrial Internet of Things. It is collecting a large amount of data, and we need to organize and reduce that data in the information. So there are some devices which enables to communicate with the software, and we take the some sensor data from the sensors. So this time series data is being generated in vast volume. So we need to manipulate that data, and we need to convert that data into the information. So we need to manage that type of time series data. So to predict that data and analyze data, we need some strong algorithms to do the same. These are my motivation. This is my research topic. So this is my motivation. The forecasting is the main and major thing in today's world. For example, suppose if in the fuel industry, suppose we take the example of fuel industry. In the fuel industry, if we cannot forecast how much data we can, how much fuel we will need in the future, so we cannot plan accordingly. So the forecasting plays an important role in the future planning. So current system has lack of accuracy, so we cannot plan accordingly. So we are trying to reduce the error by using the assemble method and trying to give the accurate result in my research. So these are some findings from my literature. I have gone through the lots of papers. So from that, I have concluded that they have used already Fuzzy time series method, linear order, minimize. They have tried to minimize the entropy principle approach, trapezoid fuzzification approach. The concept of entropy is applied to measure the degree of fuzziness. But in that, uh, I, I have seen that RMSE, root mean square error, is different for all the algorithms, and the mean obsolete percentage error is also different. But in that, I have observed that they have used the historical enrollment data and enrollment data of University of Alabama maximum time. So these are the findings of my literature. Uh, so from that literature, I have concluded that there are three algorithms that I can use. First is reduced error pruning tree. So this is a decision tree based algorithm known for simplicity and case of interpretation. Why I have selected this? Because it's suitable for capturing non-linear relationship in the data and can work well with the IoT time series. Secondly, I have taken the support vector machine regression algorithm, which is effective when I have to use a limited amount of data but want to capture intrinsic patterns. Third algorithm is a multi-layer perceptron. This multi-layer perceptron is suitable when I have used a large amount of data and want to leverage the power of deep learning. Uh, so what is basically a reduced error pruning tree? Rep tree is a decision tree based machine learning algorithm used for the regression classification task. And the main objective of rep tree is to create a tree structure that can make accurate predictions while avoiding the overfitting. So this rep tree is mainly used for avoiding overfitting, and it achieves through the process called pruning. The strength of this algorithm is it can handle both numerical and categorical features. Pruning helps to prevent overfitting and make it robust to noise in the data. Uh, so in the MLP, I have used the hidden layers 50 and 30. Activation functions is ReLU, and learning rate is 0.01. SOMRG support vector machine, we have used in my ensemble approach the kernel polynomial, and complexity parameter is 1.0 and epsilon is 0.1. In the pruning tree, reduced error pruning tree, the maximum data I have taken is 10 and leaf size is 2. Pruning is unable for generalization, though these were algorithms selected on empirical tuning to achieve optimal balance between the bias and variance. So this is my methodology. I have taken the data set. After that, incomplete data set is given to the system, and system pre-process that data based on the missing data imputations, outlier detections. After that, my algorithm, that is efficient ensemble algorithm, is applied, where I have combined the rep tree, some parameters of rep tree, SMORG, and MLP. After that, the predicted output is given. Predicted and accurate output is given. So this ensemble method involves a base learner selection. The base learner selection means I have selected three algorithms, that rep3, SMORG, and MLP. I have trained this algorithm independently on the same data and combine predictions for regression. For combining the predictions given by my algorithms, I have used a weighted averaging and stacking, and for classification, I have used a voting. Meta learner, this is the optional and the higher, which is used for the higher level model, can refine final predictions. For example, in linear regression and MLP, if I need, then I can use this meta learner. Thus, our EERA uses weighted averaging, where weights are based on the individual model performance. This is the architecture overview. Input layer, pre-processed time series IoT, that is timestamp, sensor reading, and temperature given to the as the input layer as the input data. After that, base model, rep3, SMORG, and MLP train in parallel. And after that parallel, I have applied the weighted ensemble for the output based on the validation performance, and this output layer which gives a final predictions. So in the data pre-processing, I have done the data acquisition, data cleaning, feature scaling, and data splitting. In data acquisition, The system pre-processed time series data collected from IoT devices, which include sensors, actuators, external APIs. These data typically consist of timestamp and records. Data cleaning means it cleans the data with missing data by using a forward fill methods. Feature scaling. Feature scaling is it ensures that the features are on a comparable scale, and this step is particularly important for the models like SMORG and MLP, which are sensitive to scale input data. Last one is data splitting. After cleaning and scaling, data split into a training and testing data sets with 80% used for training and 20% reserved for the evaluation and means testing. These are the performance metrics table. We can see that first one is the ERA, that is my algorithm, efficient ensemble regression algorithm. We can see the MSC, R square, MAE, RMSC, and MAP algorithm, where the MSC is 0.017, R square is 0.96, and MAE is 0.093, and RMSC is 0.1310, and MAPA is absolute percentage error is 10. So from this calculation and from this observation, we can conclude that the ensemble regression algorithm perform best in according to both three algorithms. So resource utilization statistical performance. My algorithm consumes more memory but gives an accurate result as compared to REPTRI and SMORG. We can see that the memory consume is 118 MB and REPTRI consumes 60 MB and SMORG consumes 85 MB on the same data that I have given to all the algorithms. But the standard deviation of error is 0.012 for a EERA, that is ensemble regression algorithm, and 0.034 for the REPTRI and 0.027 for the SMORG. From the memory consumption part, we have evident that ER utilizes approximately 118 MB memory, which is higher than the REPTRI SMORG, but lower than the MLP. This indicates the ERA maintains a balanced memory footprints depict combining tree model ensemble. This is the bar chart of the same. Execution time comparison. ERA completes its prediction in 4.21 seconds, which is more efficient than the MLP, but slightly slower compared to REPTRI and SMORG, demonstrating its computational viability in real-time applications. These are box plot prediction of errors. So we can see that the prediction error is less in ERA as compared to REPTRI, SMORG, and MLP. These are the actual versus predicted temperature readings. The line chart of actual versus predicted values shows a close alignment between the actual and the predicted temperature reading over a 20 times steps, where ERA effectively captures the trends of fluctuations of the time series with minimum deviation. This visual closeness reinforces ERA predictive.
We have completed our alignment mark. I just request you to kindly conclude the presentation as soon as possible.
Yes, ma'am. Yes, ma'am. These are the data set I have used. These data set I have used for the comparison. This is UCI air quality data set, which include the environmental parameters. And this is the access link. I have taken this data from UCI machine learning repository air quality data set. This is data set 2 for the comparison. And this in the same data set on the data set 2 also I have concluded that the ERA assemble my algorithm efficient ensemble regression algorithm performs good but consumes more memory as compared to other model. So finally, I can conclude that the ERA model, which combines the prediction of REPTRI, SMORG, and MLP, outperforms the individual algorithms in terms of various evaluation matrices. So we can conclude that the efficient regression algorithm is more powerful or gives more accurate result as compared to other algorithms. And these are the references that I have taken for my research. Thank you.
The latest data set you have used is how many years old?
5 years old.
The first data set you have taken, which is recorded into 2004, 2005, right?
Yes.
So it has been 20 years, and the
Yes.
things are going to be,
The,
highly changed in that particular
yes,
country.
sir.
That is what I'm asking you. That second data set you have taken up, that is recorded in which year?
Uh, it has 2020. It is in 2020.
I mean, still it has been 5 years, and
Yeah,
as
yes,
you
sir.
know that the pollution level in last 5 years has been tremendously changed. So whatever you are going to be predicted, whatever you are going to implement it in a real time, which is not going to satisfy the purpose. So it is a suggestion that whatever you are going to
Yes.
implement it, try to implement on a real time data with the
Current
latest.
data set. Yes, sir. I will implement that. I will
Okay,
take on the current data set.
sure. Thank you.
Okay. Thank you.
Thank you so much for your presentation, sir.
Thank you, sir.
Now I would like to call upon our next presenter for the session. Our next presenter is Samriddhi Ganguly, presenting a paper on the title Improving Lung Cancer Prognosis Through Data Science. I request you to kindly take over with your presentation, please.
Sure. Am I audible?
Yes, you're audible.
Is my screen visible?
Yes, now it is visible, ma'am.
All right. So, hello everyone. Good morning. I'm Samriddhi and I'll be presenting our paper Improving Lung Cancer Prognosis Through Data Science. All right. So, lung cancer, as we all know, remains a leading cause for mortality worldwide, and its early detection and prognosis is critical and crucial for improving patient outcomes. So we all know that there are various AI models that exist for the early detection and prognosis. However, a problem persists, that is, these models are not enthusiastically being implemented by the hospitals. So in our research paper, we are going to propose a formulation called the CRS, which is Clinical Readiness Score, which shows that which model would be more accurate for a particular case. So here, instead of just using accuracy, we use various other factors like interpretability, efficiency, clinical validation, and of course, accuracy. The flow of formulation. So first, we started with a literature review of the existing AI models. We collected data from these literature reviews, and a model architecture was used for the prognosis. Then a proposal and a validation of the clinical readiness score, the CRS score, was given. The evaluation of models using CRS and the results and discussion. So the problem statement, as I explained, its objective is basically to develop a robust framework to evaluate AI models for real-world clinical readiness. All right. So here we use a method called AHP, which is Analytical Hierarchy Process, to derive scientifically justified weights for the CRS factor. Now on to the domain technology and tools used. So the domain is medical and AI lung cancer prognosis. The dataset was collected from literature reviews. The technologies are the models that we are evaluating, like random forest SVM, logistic regression, deep learning like CNN, LSTM, DenseNet. I think someone's mic is on. Okay. The tools used were Python, AHP for decision analysis, Sharp, Lime, GradCam, and for interpretability and evaluation. Now onto the methodology. So as I mentioned, there are 4 factors that we used: interpretability, efficiency, clinical validation, and accuracy. We did the pairwise analysis using SATI's fundamental scale. Then we constructed an AHP matrix. Now this matrix was then normalized and the eigenvalues were calculated. The CR had to be less than 0.1, and we used sensitivity analysis to validate our understanding. Step 6 was the CRS model evaluation, where we got this formula using the final matrix, which is 0.15 times I, which is interpretability, plus 0.39 times E, which is efficiency, plus 0.39 times C, which is clinical validation, plus 0.07 times A, which is accuracy. This is a mistake in the repetition. The step 7 was to evaluate AI models on CRS and determine its clinical validity. All right, so the demonstration. So I'm sorry. Yeah, the models used were CAD for system review, CT-based tumor heterogeneity, and DenseNet 201. The process involves using IECA factors and literature analysis, metric normalization, AHV weight scoring was used as tools. Now on to the results. So as you can see, the highest CRS value was calculated for CT-based tumor heterogeneity, which matches our sensitivity analysis as well. This is the formula. So in conclusion, we aim at improving the use and the role of AI in healthcare and specifically in cancer treatment for early detection and generating trust within the medical community onto using AI. Thank you. I'm open for questions now.
Did you have implemented any algorithm specifically to detect this?
Sir, we use the AHP algorithm. First, what we did was we created. Is there an echo?
No, no, continue, please.
Okay. So first, what we did was we compared all of these four factors with each other using the SATI's method and created a matrix. Then that matrix was normalized and an eigenvalue matrix was calculated. Now, using these eigenvalue coefficients, this formula was created. And then we tested this formula using sensitivity analysis where the weights were changed and still the values remained, like the hierarchy that we got remained consistent.
How much of percentage of accuracy you received into that?
Sir, since we did not develop a model, this was just a formulation. So,
Okay. So what type
yeah.
of latest work has been done into this domain till now?
Uh, Latest work, as in this is a very new field as per our research, because nobody has yet tried to formulate to validate AI models. We aim at implementing and collaborating with hospitals after establishing this formula, because right now there's not much of trust within this community.
When you are going to implement such model along with the hospital, you must receive the real-time data from the hospital, right?
Yes, sir, exactly. We tried doing that, but because of their ethical constraints and lack of trust, that was a problem. So that was one of our challenges.
But before you are going to start with the real-time problem along with the hospital, you have to have so the proven result based on the secondary data what you have already implemented.
Yes, sir, exactly. So we aim at establishing the formula first and then going to hospitals to gather their data sets.
All right, fine, thank you.
Yeah, thank you.
Thank you so much for your presentation. I'd like to call upon our next presenter for this meeting. Our next presenter is Prafulla Bafna, presenting a paper on the title Meta for Pre-Construction Settings. I request you, ma'am, to kindly take over with the presentation, please.
Good evening, ma'am. Am I audible?
Yes, sir, you're audible.
Yeah, so sorry, ma'am. So Prafulla ma'am couldn't be here due to some technical constraints. So me and my colleague Lokesh will be presenting. I am the corresponding author, and Lokesh is one of the author of the paper. So
Understood.
we will be presenting on her behalf. So if you want, we will just go ahead with the presentation.
For sure, sir, for sure.
So thank you.
Thank you.
All right. Good morning to all the panel members present here today. Me and my colleague Lokesh are going to present our paper Meta for pre-construction sales. So I request Lokesh to go on next slide. So the problem right now which we face is that when the construction activities start, or typically when we go, for example, we go and see one property that we are interested to purchase, the first thing that comes to our mind is that how it will actually look. And that's where the builders do build a sample flat or sample property area to demonstrate that how the property is going to look or how they are going to visualize it. But having said that, all these activities take place at a very later stage when the whole building is ready, and you actually don't know that how this sample presentation that builder is providing is actually going to perform both by customer side and by the builder side, as this is something that as a customer needs to interpret, takes time for to make decisions. For construction projects, majorly in India, what builders do is that once they purchase the land, they start selling the property itself, as they need to secure some procurement funds for these activities. And for that, they sell their property at a very reasonable rate as compared to later stage when the whole property is ready and they are selling the sample flats. But at pre-construction stage, that during the procurement time, when I say that they are selling the property at a cheaper rates, they need some tool to make customer buy that property itself, right? Because if I don't have some sort of visualization in front of me, how will I make decision that my future home is going to look? For that, typically right now, what builders or in any industry we get to see is rendered images of the property, and that's the problem, right? Because when the whole building is not ready and you are just presenting some sort of image in front of me as a customer, then I cannot make a certain decision that will be around my lifetime decision, I would say, because I'm going to stay in that property for my lifetime. So for that, there needs to be some customization, some immersive experience for customers so that they can actually view how their future home is going to look. And this will directly lead to increase in sales of the property at a pre-construction sales and will secure a procurement for builders itself. And second issues is that, as said, that if they don't are not able to sell their property at a pre-construction stage, when the property is ready itself and all those sample flats are ready, then there are many projects in India that go unfinished or are half empty. So there needs to be some parameters for builders that they can decide that whatever they're trying to sell is actually shown interest by the customer. Lokesh, next slide. So yeah, from now, Lokesh can explain the objectives what we're trying to build.
So here we are actually building a project, a prototype in which we can show the actual customers how the property will look like. For this instance, we have taken Unity, but this can be made on engines such as Unreal, CryEngine, or these are open source engines, and you can also go with paid engines such as uh, it's Room Sketch or Lifesize Plan. Lifesize Plan is a it's a startup which creates a project like a room, for instance, to make customer more believable, and it just creates an asset on which we can view it. So this will help customers to make their decisions quickly, as they can interact with the scene as well as they can view how the lightings are, how it will look like after they do their customizations and everything. So this can be cost effective, as such they don't have to create like flow plans, and then they have to create a whole sample flat, so that they have to show the clients like how the room looks like, how will be the like how tall will the ceilings be, and as such. And this can help gain trust, let's grasp the trust of the clients, and then we can move forward with it. So carry on. Just
Yeah, so approach that we are applying right now is that we want to present a typical metaverse or a meta development where we are providing a virtual version of the property that client will actually be looking to buy. Or in simple words, rather than presenting a sample flat, which is at a very later stage, what the builder can do is during the pre-construction phase, that is during the procurement activities, they can just build a virtual environment of the property that they're looking to sell, which gives much more immersive experience to the consumer side, as they can interact with the property that they're actually going to looking to buy. And this itself would also lead builders to understand that what they're lacking during the their plans during in their plans, and also it would enable builders to cater different customers by providing different plans. So that's one thing. And as compared to traditional approach, which I just said during the introduction part, that is just static rendered images, 3D images, which are not interactive, and it becomes confusing for a customer side because they need to understand that how the actual view is going to look if they look outside the property, or how their rooms are actually going to look, and how the navigation will be there. Like once you open the door, where do you see your bedroom or your hall at different locations? Because in India we do have different type of trust, such as Vastu is one of the biggest thing that is there. So yeah, now let's move on to next slide. So in terms of methodology, as said that we are trying to present a framework so that there should be a immersive experience or a metaverse for customers to make a better decision making, and for builder side as a sales instrument to get their sales right during the pre-construction phase. And as said that this will also lead in less abundant properties, and also for builders to cater changes in the early stages to make sure that demand goes right during the later stages when the sample flat is ready. So that's the whole objective. From next slide onwards, we will demonstrate one of the prototype that we had built using the Unity, and Lokesh will demonstrate that.
Let me change the showcase real quick. So this is Unity in which the project is made on. So let me just show you the demonstration. Yes. So this is how you can move around and then see how the room looks. And then you can also interact and move with WASD so that you can move around and check out how your stuff and the room would look like, how tall are the ceilings, how would light look like. And then you can go ahead, go up, down, and then view the kitchen, as well as you can view the rooms. And then for this, you also see on the bottom right, bottom left corner that there is a timer. So like we can track time on how much we are like what is the time, how much the customer is spending on each room, as well as like how much they are doing interacting with the session. And then also you can view, so we can fetch through APIs and stuff like the real time. So if I want to change time, like how will it look like in the evening, morning, we can change time and then see how the lighting conditions are in the room. Because in sample flat, you don't know exactly where the flat would be. So the lightings can change as per the locations. So I will move on to next to presentation. So this is methodology testing. So users was compared against traditional static image. So like let's take an instance like users given getting a feedback from users comparing between the interactive or gamified version of this uh, project against static images which are provided by the builders. Then this can involve let's involve the real estate agents as well as the potential buyers so that they can provide essential feedbacks on how we can improve or how can we make refinements to this project. Then moving forward, I'll just take a
So as said, key features you were able to see in prototype. Obviously, we are not explaining the complete walkthrough because it's very simple. You understand that we have created a virtual version of a property, and you can go and explore that different rooms, different viewpoints. Key features, again, I would say one of the challenges that is Vastu. So you would able to see that whether the flat is falling as per the Vastu's directions. And second thing is that you can also be able to view your property in real time. As said by Lokesh, that by real time, I mean how the lightings will be there in your flat, or how the light would enter your property through the window panels. And there are no as such limitation. I would say there are many much more advantages because in terms of scaling, you can just create a sample property, like just we created a simple room, or you can just create a, for example, let's say a whole society itself. So you can just show that how your environment will be for the whole society, how parkings will look like, and you can just provide a complete walkthrough. In terms of deployment, also it's very simple. As the framework which we used was Unity, so Unity does has a WebGL deployment option too, but it's not a compulsion that you need to use Unity. There are other tools available too in the market, as explained by my colleague Lokesh earlier. Next slide.
Before we move on, sir, I just need to inform you that we have crossed our 10-minute mark. So I just request
Yeah,
you to
sure. I'm
kindly
just
conclude.
concluding.
Thank you, sir.
So future scope itself, I would say that you can just enable the cross-platform integrations such as 360-degree view platforms such as AR or even VR headsets and machine learning algorithms. With the timer, you can predict that whether the customer is going to buy that property or not. And lastly, I would also say that it's a good option for exploration, and there are many tools available in the market. And this type of solution is particularly not been enabled in India or is available in India right now. So that's for the concluding part. Thank you. So if there are any questions, we can take up.
So you have made up a 3D model just to visualize that how your flat or home is going to be looks like. So in which particular application user has to see that? Because whatever the model you have seen, this is a 3D model which require lots of graphical representation and space. So it is normally visible in any of the mobile.
Yes, as said that the framework which we are using, Unity, it does have a web deployment framework itself, WebGL. So it can be deployed as a website, and you can just go ahead and type the domain of that, and you can view that.
So it is going to be visualized through website only, right?
So as said that this is just one tool that we have used for this, right? Unity is just one part. For example, there are other tools in the market such as Room Sketcher is there. So that's a paid plan. So in that also, obviously there are both options. You can send an offline file itself to view it, and there is also their platform application where you can view that. For Unity, yes, you can go ahead and view it on website. So ultimately, what I'm saying is there is no restrictions how you want to display the property. Right? You can either go it and sell it as an application or even on web deployment as said as a website.
All right. Thank you.
All right. Thank you, everyone.
Thank you so much for your presentation, sir. I would like to call upon our next presenter for this session. Our next presenter is Ajay V, presenting a paper on the title Multi-Label Emotion Classification from Data Text based on AI techniques. I request you to kindly take over the presentation, please.
Ma'am, am I audible?
Yes, sir.
Okay, thank you. Ma'am, is screen visible?
Yes, sir. Your screen is visible to us.
Okay. Good morning, everyone. Today, I would like to take a review paper on the topic based on multi-label emotion classification from text-based on AI techniques. I'm JV, and our co-authors are Sharon Pierce, Philomena Simon, Ambly George, and Mehana Shahul. This is the table of contents. First of all, on introduction, emotions are the fundamentals to human communications, influencing the percepting and other behaviors and accepting our interactions. With the in the digital communication like social media, chats and blogs, detecting emotions from text has become essential. So that some of them they use the traditional sentiment analysis that positive, negative, neutral is so simplistic to capture the real emotion, real human emotion complexity. People often express the multiple conflicting emotions simultaneously, but requiring that they must be some requires a multi-level classification. So there the application for the emotion aware systems are vital for chatbots, mental health tools, social monitoring, and must work multilingual and informal texts. Now look at the on the motivation section. Traditional sentimental analysis failed to capture. It means that the complex values like multiple emotions are failed to capture by traditional sentiment analysis. So that is why we use the multi-level classification is essential for the real-world text like social media and dialogues. So that means AI improve the virtual assistance, mental health tool, and crisis response system. There is a need for the model to handle the complex mixed and informal text. Means that multiple emotions that and sentences and languages must be handled by there is need for the models. So they are vary for the linguistic and cultural institution. Our problem statement of this is the real world text often contains multiple overlapping emotions, making the single label classification integrated. They so that we by using the contextual languages and structure posing the challenges for traditional models, especially in the multilingual or informative. So our objective is to investigate the efficiency of the different methodologies that can be given in here. We have so many models that have been investigate it, and also we have to review the traditional and other advanced learning techniques like BERT, Roberta, and used for the multi-level emotion classification of the text, and also to analyze the modern dataset and models to handle the emotion overlap of the code mixed languages. So this is the I have covered a lot of 22 of literature review, but on the limited times of this, I will show the literature reviews as a part of a short details. So as per that, I will explain about the data set that are performed on each literature review papers. So in here, first of all, MESD dataset is the English and its type is the multimodal, means multiple text, audio, video can be represented, dialogues and labels. This on the MESD used for dialogue labeled for the emotions. And next one is emotion Hindi, and it is a Hindi English must be there. This must be the code mixed text. So multi-level real world conversations data from the Indian users key features, and also Let's Ball and at last Roman Urdu tweets that must be the Urdu, and Roman Urdu must be texts like social media type and lower resources and code switching and mixed script emotional content. Now let's move on to the architecture of the multi-level emotion. Here, input text is passed through the text processing. They will do is to remove the irrelevant and elements and also convert the raw data into a standardized input to form the tokenizing and normalizing, ensuring the consistency. And also after that all process is done, they move to the feature representation. What they use to, with the help of the bank of words and a TF-IDF of the traditional approaches, numerical, they will the process of text into a numerical vectors. After that, employs the deep learning embedding word to word block and contextual message to capture the sentimental context. After that, it move to the feature. After this process done, they move to the feature selection. Feature selection is to identify and retain the information features and reducing the noises from the text and dimensionality, and improves the model efficiency and predict the accuracy of focusing of relevant data attribute. After that, we use the main model of multi-level emotional. It is a deep model perform the BERT. BERT is performed as bidirectional representation of the text. They do with the help of the Roberta to get the contextual meanings and all. After that, they move the emotion classification modeling. What they do is to models relationship between the different emotion models to account for occurrence and dependencies, and enhance for capturing by enhance classification by capturing emotion overlap and improving the accuracy in the multi-level picture. This is architecture. I have definitions. After that, on the discussion part, we have been analyzed. We have been find out that the evolution of techniques. The first of all is the evolution of technique. First of all, first section is rule-based techniques used for emotion lessons, and if then rules but fail to capture the context and mix it emotion. So in here, we have used then after that it moved to the statistical model. Statistical model introduces the automation, so SVM, naive bias, including but treated the label independently. But some of the missing emotional overlaps they become so that after that we they use the neural network like CNN and convolutional neural bytelation to improve the learning from the word sequences and syntax structure, offering the better capture. And also, like, the latest model is transformer. Transformers were used as a BERT, Robert, XLMR, and revolutionized for the field by using the self-attention to attend the context and nuisance. On the and also with the and also disambiguate the complex phrases, understand the sarcasm, adapt well to be code fixed and short and multiple lingual text. And a new method like LSPCL and graph neural networks model that dependencies improve the accuracy and reduce the label imbalance. This allows the system to better reflect the human emotion states. Now let's move to the dataset innovation that we have find out from the found out this overall literature review paper. This means that the dataset like the emotional Hindi and Roman Urdu models can handle the hybrid language. This means that they want the hybrid languages. This combination of both the contextual embedding and semantic embedding. So these texts combine the religions word of English words and then the challenges. Some of the challenges may come for the dataset combination. Well, first of all, they tokenize it, then it translate it, and they vectors into emotional code. This must be the very good challenge. And Traffic introduced the close-based annotated for the deep emotional detection. And it helps to identify, we have to identify the emotion shifts from the senses, improve the graduality and interpretability. From the on the dialogue histories, the model understands the emotions in a conversational context, not that isolated sentences. And also, it is essentially for the multilingual and multimodal dataset must be there. After that, we have found out the another is the real world usability. They also emphasize the echo models of benchmark model on carbon emission and trading type and accuracy. This versus the vision of the transformers. It means that the transformers usage and auto ML in the large scale tasks. And also, real-time data must be noisy and informal and emotionally ambiguous from we have taken from the social media. And also only the models that can only adopt the short text emotion emojis and sarcasm and slang must be there. And it is very difficult to adapt the need the domain adaptive models for the code mixed and low resource languages. And also system must generalize across a linguistic and a contextual cultural context for globally applicability. This means that there must be the dataset words must be tones and some of the words or misspellings must be there. There must be have to capture it. And after that, there will be the key areas are the used for the techniques era, role-based statistical ML, neural network, and transform models. These are the transform models. They are used as a BERT and Robert XLMR, and their limitations will be deep contextual and semantic awareness must be there, and the state-of-art performance. So, and also the latest emotion correlation model at GCNs and emotional artists and require sophisticated modeling of this. In our key conclusion or key findings is to multi-level emotional confidence is more accurate than the single levels in for the real life expressions. Now they move to the latest model as the transform models with the transform models like Bert and Roberta. Is a bidirectional representation of text. So it contracts the learning to outperform the traditional models, and also attention mechanism and emotion correlation must be used for to improve the classification of the dataset and all. So dataset with a linguistic diversity and emotional complexity must be essential, and we can use the variety of applications of benefit of mental health, virtual engines, and social monitoring. These are the references that I have included on this PPT. And thank you, sir.
Have you checked this algorithm by applying any of the real-time data by entering some, text from your side?
Sir, this is a review paper from the hello, sir.
Okay, fine. Thank you.
Sir, this is a review paper that I have been paper, but I am a MS student, so I will apply to the model as a transsource-based model as Roberta plus fastest, which is context embedding and semantic embedding. This will combine to form. You have to be developed a new models based on that, sir.
Okay, fine. Thank you.
Okay, sir. Thank you.
Thank you so much for your presentation, sir. Now I would like to call upon, thank you so much. I would like to call upon our next presenter for this session, Gauri Shaju, presenting a paper on the title Optimized Feature-Based Machine Learning Models for Breast Cancer Detection. I request you to kindly present your paper.
So, good morning, everyone. My name is Gauri Shaju, and I'm here to do my presentation on my paper, which is titled Optimized Feature-Based Machine Learning Models for Breast Cancer Detection. Moving on to the introduction, as we all know that breast cancer is one of the common type of cancers mostly seen in women. It occurs when the cells in the breast region starts growing uncontrollably and which can be felt as a lump or can be detected using various detection techniques. So here, these detection techniques include histopathology, a mammogram, ultrasound, etc. Now here in my study, I have focused on histopathology, which is the study of a disease at a cellular level. Now, here we have used two data sets, one which is already a feature set and other which we have manually extracted, and we have done a comparative study on how machine learning model predictions can be improved using optimized feature sets. So we have used population-based evolutionary optimization algorithms for the comparison. So as we know that the redundancy in the data sets can lead to low accuracy in our predictions. The application of optimization algorithms helps in removing this redundancy and giving better accurate predictions. Now, the data set used. So I have used here two data sets. The first one is the Wisconsin data set. So it consists of 569 instances and a total of 32 attributes, of which 30 are the features of the nuclei. And this data set is already extracted from the histopathology images and available in the CSV format. Now, the next one, we have mitosis atypia database. So this data set, it consists of histopathology images, a total of 2,127 histopathology images. And here, from this data set, we have extracted handcrafted features for training our models. Moving on to the methodology. As I have already mentioned that we have considered two data sets, the one which needs the Wisconsin, which needs to be classified as benign or malignant, and the second one which consists of images that needs to be classified as mitotic or non-mitotic. So each of these histopathology images, it consists of many nuclei. So first, we obtain patches using blue ratio conversion and hysteresis thresholding and bounding boxes from these histopathology images to obtain our region of interest. From that, we have we have handcrafted a total of 144 features, of which 10 are shape-based features, 34 are texture-based features, and 100 are hope-based features. Now, as we have our feature data sets, we train 4 commonly used machine learning models for calculating the accuracy, and then we apply these two feature sets to the optimization algorithms. Here I have used 5 optimization algorithms, which are particle swarm optimization, ant colony optimization, whale optimization, genetic algorithm, and also differential optimization. And for each of these data sets, we have obtained optimized feature data sets from each of these algorithms. And we have trained the 4 different classifiers using each of these optimized feature sets to see the to observe the results and do the comparison. Moving on to the results. So for Wisconsin dataset is comparatively a small dataset, and for that, as we can see, for the 2 models, logistic regression and random forest, we have already attained, without optimization, we have already attained accuracies above 95%. But for SVM and KNN, we have not obtained that much accuracy. And here we can see that for all the models, after applying each of these optimization algorithms, we got improved accuracies, as well as the other metric values have also improved. With logistic regression model, when trained using the feature set which we have obtained from genetic algorithm, has got the highest accuracy of 98%. Now, for mitosis atypia database, here when compared to the Wisconsin dataset, the accuracies are comparatively low since due to the limitation of handcrafted features. Now we can here also, but we can see that the optimization algorithms has lead to a better accuracy and other metric values, with random forest trained with optimized feature set from genetic algorithm being the best one with an accuracy of 80%. Moving on to the conclusion. From the results of this study, it can be observed that the application of each optimization algorithm to each of these data sets and training the models using those optimized feature sets has led to more accurate predictions. And it is also observed that how different optimization algorithms affect the performance of different models. So that's all about the presentation. Thank you.
So for the breast cancer, actually, the mammograms images are also useful. So have you tried the same thing with mammogram images?
So, sorry, sir, could you please repeat the question?
For breast cancer detection, actually the mammograms images are more effective. So whatever the algorithm you are trying to implement, histopathology images are okay. But if you are going to check the same result with the mammogram images, give you more accurate idea about the algorithm performance.
Yes, sir, but we haven't tried with mammogram images. We have only focused on histopathology images now.
But if you wanted to make it more stronger about your research, you always go with the mammogram images as well.
Okay, sir. Okay, I will try with that also.
Sure, thank you.
Thank you.
Thank you so much for your presentation, ma'am. Now I would like to call upon our next presenter for this session. Our next presenter is Kalyana Sundaram B, presenting a paper on the title Real-Time Stock Forecasting and User Verification using Azure AI Services. I request you to kindly take over with your presentation, please.
Oh, yes, ma'am. Am I audible?
Yes.
Okay. I'm sharing my screen. Is my screen visible as well?
Kindly give it a minute, so 1 second.
Yeah.
Yes, now it is visible.
Oh, okay. Thank you. So yeah. Good morning, professors and the organizers of the conference. Myself, I will go with my introduction first. Myself, Kalyana Sundaram. I'm a 5th year MTech integrated software engineering student from Vellore Institute of Technology, Chennai. And I'm a Microsoft student ambassador to present the paper Real-Time Stock Forecasting and User Verification using Azure AI Services. And this is the outline of my presentation today. We are going to, I'm going to speak about the motivation, background work, proposed method, results, conclusion, future works, as well as the references I have used for the paper. And the main motivation is we have combined 3 major services. One is the invoice management, and next one is KYC verification, and another one is stock-based prediction. We have done all these things via Azure AI services. So Azure AI services, basically the cloud service provided by Microsoft, where many of the services like OCR and document intelligence and machine learning studio and most of the services are available there itself. And we are using that as an endpoint based development. So the stock markets are highly volatile. So we are gonna build a recommendation based system, and a traditional trading platform lack agility and face severe security threats. And next thing what we are doing is the KYC verification that will be automated in this platform as well. And this platform is built the front end with the Flutter, and the back end is mostly on the Azure platform and the endpoint. So the background work, these are some of the background work we have done, and there are more than 15 references. Out of that, I have picked up 3 references for the presentation. The first one is predicting market performance using machine and deep learning techniques, and accurate stock price forecasting based on deep learning and hierarchical sequential decomposition. And out of this, what we have found is there are many hard coding code available in the background work and literature review. Either they have trained the data set and they have built a platform. But what we are doing here is we are using a technology called AutoML. I'll be explaining that in my next slides. So yeah, the novelty here is we are integration of the Azure AutoML for real-time for stock forecasting. We are feeding the data to the automated machine learning and deployment of Azure document intelligence for KYC verification as well as in invoice management, and the use of AI-powered invoice management for automated text extraction. So if we upload an image, the text will be extracted and it will be uploaded to the DB storage. And end-to-end secure scalable trading platforms, the cross-platform compatibility, that is Flutter. For now, we built for the web version, not for the mobile like Android or iOS, and the Azure backend. Flutter for front-end and Azure as a backend. So there are 4 main things I have to discuss about in the methodology part. One is the architecture and the data processing and predictive modeling and user verification and the cloud deployment. So the first one is architecture. So the architect, I will explain the architecture in the next slide with an diagram. So we'll go with the data pre-processing. So the data pre-processing is nothing but we have fed the data we got from the Yahoo Stocks, Yahoo Finance, about Microsoft, and the data from 2020 data to the Azure AutoML. And what it does is, there are many features in the particular data set. It's a form of CSV, and the closing values are target variable, and others are like high, low. All these things will be our prediction. So we have fed that, and there is an inbuilt model in Azure Machine Learning Studio where it will be trained and it will be giving a results. The training hour we took it is around 6 to 7 hours. So that's the data pre-processing step. And user verification. User verification is nothing but there is one service called Azure Document Intelligence. We have created and deployed the Azure Document Intelligence, and we got the key and point, and we have used in the Flutter for the compatibility purposes. And cloud deployment is everything is done there in cloud itself. In Australia East for storing all the invoices and the KYC verification. Like we have used Aadhaar here for KYC verification. Uh, am I audible? Like I'm getting a message like your internet is unstable. Uh,
You're audible, however, in between there is a glitch.
okay, I'm sorry. Yeah, am I audible now, right?
Yes, yes, you're audible.
Okay, fine. And yeah, the key vault and the Azure DB for the storage purposes, and the ML workspace called Azure Machine Learning Studio, where it is like a virtual ML workspace. So this is our system architecture. So our application is Trackers, and what we're gonna use, the stock market API is nothing but the endpoint we deployed via the AutoML part, which is done in the Azure. And next one is document intelligence for KYC and the invoice management, and the Azure AutoML to feed the data, and Azure OpenAI. Azure OpenAI is a service. Why we are using that is we have done a summary based thing. We'll be getting a graph, and out of that, the Azure OpenAI will summarize the things about what is discussed in the particular graph. But while submitting the paper, we got a suggestion that deploy a recommendation as well, like you have to buy a stock or not. So that also we have used Azure API for that to recommend them to buy a stock or not. And Azure DB storage, yes, it is to store and retrieve the market data and the user data, like government verified Aadhaar card or something like that. So we have used Azure DB storage as well. So all this come under Azure App Services. Azure App Services is to deploy a particular app in Azure. That's the main thing, and it will go to the application as well. So the modules we are using is stock forecasting module, user verification module, invoice management module, and user interface module. Yeah, these are the 4 modules we are using. Yes, this is our interface. The first one is invoice management, and second one is KYC verification, and next one is stock risk prediction. So in invoice management, what we do is here there is one PNG based invoice which is uploaded to the application, and what it will do is it will convert the image to text in the form of table. Here the backend behind it is document intelligence. We are using it. And the next part is KYC verification. KYC verification is nothing but you'll be uploading your Aadhaar card. And if any spaces or any of them is wrong from your manually entered and your upload Aadhaar card, it will be showing that KYC verification is failed, else it is successful. And this metrics like R square, all these things is for the stock verification. We got around 0.9998 for the stock prediction purposes. That is on the next slide. Yes, here we go. This is the main part. We will be manually entering the high value, low value, average choice, volume, and all these things, and it will be predicting. This predicted stock value is 0.931. So we have this 0.931 will be equal to in the Yahoo stocks of Microsoft. So almost it will be as 0.930, a 0.001% will be differing, but we got an accurate result of that. And next, what it will do is here that we are generating a summary as well. Here, the summary is about the key points and the market prediction and all these things. It is done via Azure OpenAI services. And this is a training graph we are getting. And this is how the predicted stock is done. So at last, when it comes to conclusion, we have taken a new approach called Azure AutoML. And we have made a research on Azure AutoML as well. AutoML is not being successful in healthcare, so we thought of making that efficient in the stock and the prediction forecasting as well. And the AI-powered trading platform for integrating the predictive analytics. And our research is not stopping here. This we are taking the KYC to the next level. That is to improve the AutoML retaining part. And next part is the KYC is now done in cloud. So the latency might be a issue for us. So what we have thought is we can include blockchain, technology called Hyperledger. It's a private blockchain where you can verify your KYC and it will be converted to hash, so that there won't be any tampering of KYC, there won't be any data loss. So that's what we are going to develop it. The KYC verification with biometric verification, multi-layer security, that is Hyperledger, and the integrate blockchain-based transaction. Now everything is on cloud. Instead of cloud, we will be going for Hyperledger next. So Hyperledger is a private blockchain-based database where you can store your data as well, and it will be converted to a blockchain-based hash code. And to handle the extreme volatility using advanced risk management modules. So this is our research paper is about, and thank you. And these are the references we have used.
My question comes to KYC. When you are asking somebody to upload the Aadhaar card, how you are going to ensure the safety and security of that uploaded Aadhaar card with your application?
Sir, the thing is like for KYC verification, it's nothing but they will upload their Aadhaar card. And the Aadhaar card, we have developed an application with all the spacing issues and all it's done, and they will manually enter their details as well, the first name, last name, and the Aadhaar number, and the Aadhaar card they will upload. So what the document intelligence will do is it will compare these two things, and then it will come to a conclusion that it is successful or failed. So that's all. And now the cloud is like we have used the TCP as a firewall. So to enhance the security, we thought of moving to Hyperledger.
So what I understand from my answer is you ask for a user to upload the Aadhaar card, and then you are also asking for the manual entry, and you are going to check both those entry whether they are same or not. Is it so?
Yes, sir. So it will be all the things will be
Then,
stored in
then
the
there,
data.
there might be a chance of fraud. I mean, you must be have to have a checking with the standard database of Aadhaar card. Otherwise, people can manually generate Aadhaar card, and they are also going to enter those things. How you are going to verify them?
Like there will be there's a backend DB like that
Your
DB
voice is not
storage which will
clear.
be approving that for now for the presentation purposes, we have shown that the KYC is successful or not. But in the Azure DB storage, we are using that. There it will be manually uploaded by backend people there. So.
That's fine. Okay, but for if you wanted to making this particular application more reliable, you must be have to check out or verify that particular whatever document with the standard database, whatever available on public.
We have to link it to the mother database as well.
For that, you require, of course, a permission, and which is quite tough, I guess.
Yes, sir. We will try to do that, but yes, sir. That's a session I can take. Sir.
Okay. Okay. Fine. Thank you.
Thank you so much for your presentation. Now I would like to call upon our next presenter for the session. Our last presenter, Hanish KM, presenting a paper on the title Sensor Integrated Smart Pump for Deep Vein Thrombosis Prevention. I request you to kindly take over with your presentation, please.
Screen is visible?
Yes, sir, your screen is visible.
Okay. Good morning. So I'm going to present a paper on the sensor integrated smart pump for deep vein thrombosis the prevention. Okay. So myself Hanish KM. So the George Sebastian, Anandakrishna Menon, Miguel Newton, and Sonal Shaju are my co-authors. This one. So in this work, what we are doing is we are presenting a smart AI driven the deep vein thrombosis prevention system. Okay, so which is having additional the comfort and the AI integration compared with the traditional cups using for DVC prevention. Okay, and this is enabling the autonomous and rapid response and the more user friendly and it is more effective in clothes easier than the conventional DVT pumps. The coming deep vein thrombosis, am I audible? Yeah. So the deep vein thrombosis basically means if you are, especially those who are the continuously in the bed rest for longer the period, okay, and those who are recovering from the surgery, so they may not be moving their legs or the arms the more frequently. So there is a chance that there can be some blood clots in the deep veins of their lower limbs. Okay, so that is what is known as the deep vein thrombosis, and this the prolonged immobility may be causing this the blood clots in the vein, and the major risk is that these clots may burst and it may the flowing through the blood veins, and finally it may be reaching into the heart or some major vein, so it can cause the issues like the heart attacks, or it is what is generally known as the pulmonary embolism. Okay, so that is why it is a major health risk. So we need to identify them earlier, or we need to successfully prevent them in such the potential cases. Okay, so and what are the major suggestions usually the doctors advise for those who are having the risk of the prolonged immobility? So it is better. Some people, if you are even when they are traveling for long hours, if they are not moving their limbs and all, still such cases there can be a chance of the deep vein thrombosis. So the doctors advise to walk and stretch regularly. Even for the bedridden patients, they will suggest to do some kind of exercise. Okay, and the other one is sometimes they'll be compressing the lower limb by using some cuffs. Okay, and then they need to keep their legs. Okay, so for some frequently they need to move their legs, so the chance of the deep vein thrombosis is reduced. Okay, the other major method is then the doctors may be giving some the medicines, okay, basically some anticoagulants to avoid the clotting of blood. So that are the general methods used to avoid the deep vein thrombosis. And one of the easier and effective method for deep vein thrombosis production and the is to prevent the deep vein thrombosis are the graduated compression stokings. Okay, so usually they'll be having a compression stoking which will be compressed frequently by using pumping air into that. Okay, so this will be giving a exercise for the bedridden patients. Okay, so they can will be setting some times for the compression, and then will be giving the frequent the compression and decompression, so that the blood flow in the veins will be more frequent. So this can reduce most of the DVT chance, okay, so that the blood flow will be more regular. So the studies saying that the the DVT risk will be reduced by at least by 65% by doing this one. Okay, but there are some challenges with the traditional graduated compression stokings. Okay, so presently these compression stokings are available in the market, but it is manually operated. So usually the patient or the bystander will keeping it for a certain time period. Okay, so that time we are not taking any feedback regularly whether the compression is the sufficient. So usually it is not done by any medical the practitioners or the support staff. So usually it is done by some patients or bystanders. So whether the compression is sufficient to get the blood flow correctly, whether is there any over compression is happening, or any the compression any particular point any heating is happening, so that we are not taking the feedback. So that makes, okay, sometimes it is uncomfortable for the patient, so they may not be using it regularly. Sometimes the compression may not be sufficient, so this may all lead to the DVT, or sometimes the patients are not actually regularly using that one. So, and also there is issues like the oversetting happens when you are compressing more, and when you are the muscle movements may not be proper. So that are the major challenges with the traditional the deep vein thrombosis pump. Okay, so what I mean during the market study, so we had gone through a few research papers. Also we had the consult with some of the doctors. So what they are suggesting is, if we can make it more smarter, then it will be more comfortable. And actually we had one or two patients. So in that particular patients, actually the suggestion came from them. Okay, so to make it the more the smarter, so that the bystander or patient need not check it regularly, so that you can put it in the automatic mode, and then you can do. So what we need to do is, we need to make it smart. To make it smart, we need to collect more feedback. We need to include some census. So through that census, we'll be sensing the data. Based on that sensed data, we can control the compression pressure and the compression duration, and even will be going to the AI integration into that particular part. Okay. So what are the major pressure sensors we are incorporated is the pressure sensor to know whether the compression is sufficient. Okay, the issue is that the different patients may be having different muscle strength. Okay, some of them may be the old patients. Some of them may be having some sports injury. They'll be maybe having some stronger muscles. Okay, and they so depending on the patient, we need to sense it, and we need to give it. And then temperature, if any hot spots is created, or overheating is there, or the patient may be feeling uncomfortable with that. And then there will be sweating happens. Okay, so that is not good. If inside the sleeves, if the sweating happens, that means the compression is not proper, or the patient needs some relief. Okay, and then actually the accelerometer we can keep to check whether the movement is there, whether the patient is moving, or if it is keeping still. And then the muscle, how the muscles are going. So we can have the surface EMG sensor. Okay, to ensure that. So this is the outline. So we'll be having the some sensors, the pressure, temperature, moisture, and EMG sensor. Usually this will be keeping on the patient's the lower limb, okay, inside the sleeves, okay, so that it will be directly taking the readings from the patient's the body, the surface of the patient. Then this data will be taken into the microcontroller, and based on the microcontroller program, so it will be from the sense data, and we can have the program to control our motor pumping. So the what pressure we need to pump and what is the time duration we need to pump. So that will be controlled through a solenoid valve, because it is a compression and decompression cycle. So that is controlled through the solenoid valve. Okay, so these are the components used. We have used the pressure sensor, the moisture sensor, the EMG sensor, and the temperature sensor. Okay, so this is the complete hardware setup. Okay, so which we have made it as a prototype. Okay, so you can see that these are the kind of the compression stockings which we are using in the usually on the lower limb. Okay, and then this by using the motor we will be able to control the pumping and the compression and decompression. So these are the solenoid valve to control, and if we have few sensors, usually that sensors will be going into the inside the stockings, and the microcontroller is a Arduino based, what we are tested with an Arduino based system, so that we can the control that the pumping timing and pressure by using the sensor inputs. Okay, so now what the next level, so we are trying to integrate the AI into that one. Okay, so that it can run in the automatic mode. Okay, so from these sensors we'll take the data and we'll be sending to the microcontroller. So presently at this stage we have in the prototype stage, what we are doing is we are sending the data into the laptop, okay, where we are running the program, AI based program. Based on this sensor data, we'll be generating the different PWM signal, that is the control signal, to the motor, okay, so that you can control the motor, the pressure, as well as the direction of the movement, the what is the time duration for the compression. Okay, so these are the some the results which you have got. So these are the pressure, temperature, and the moisture data, and based on that we are generating the PWM pulse, the pulse width modulated pulse, for the motor to control it. Okay, and
Sorry
this
to
is
disturb you, sir.
yes.
We have crossed our time in a duration of 10
Yeah,
minutes.
yeah,
Just request you to kindly find that soon.
okay. So these are the simulation results. Okay, so we are simulated for different temperatures, and we have done the testing on some healthy adults. Okay, so actually for doing the patients we need doctor's permissions. We will be doing that once we done the AA one. So it is working well. So we are done under different testings. Okay, so this the proposed system is much more effective than the conventional system in terms of the comfort and the ease of use, and it will be the advanced version of that. Okay, so this AI integration of this into the DVT pump will be a good thing, so that it will be giving benefit to a lot of the patient as well as the bystanders. Okay, these are the major references which I used. Okay, thank you.
So you have developed a prototype over there. So what is going to be displayed as an output to LED or LCD? What you have collected?
Yeah, actually the sensor values and we are displayed, and also the motor speed we are displayed. So that presently that are the only thing we are displaying. So the actually we want to make it compact. So usually the display may not be required for that one. So but the if you want to integrate the AI, so that stage we are presently done only with the laptop. So we need to make it as a smaller module, and we need to develop it as a complete product.
Okay, fine.
Thank you so much for your presentation, sir.
Thank you, sir. Thank you.
Thank you. With this, we come to the end of our session. I sincerely thank our authors for their excellent presentation and contribution in this session, and all our participants for being a part of this international conference. I hope this session was informative enough We, on behalf of the whole team, thank you for your support during this 10th version and all the previous 9 versions of this conference. We will be happy to have you in the 11th version in 2026. All the presenters would be getting their digital certification through email within the 2 working days. Further, all the papers have already been forwarded to the Springer. The publication will be live within 7 to 8 months. Kindly cooperate with the team of ICT4SD 2025. I would also like to thank our session chair, Dr. Upesh Patel, for chairing our session. Thank you so much, sir, for chairing our session.
Thank you, ma'am.
So here's a token of appreciation from our team of ICT and Global Knowledge Research Foundation and partners. Any final thoughts before we conclude our session, sir?
Thank you all the participant for your informative research sharing knowledge session. And best of luck for your future research work. Keep updating your knowledge and sharing with the community via such a conference. We are happy to help you in every order technically that how you are going to be improve in your research area and try to improve the nation. Thank you.
Thank you so much, sir. I'll just request all of you all to kindly switch on to your cameras for a quick snapshot of. Thank you so much. Stay safe and take care. We'll meet in the 11th version of this international conference. Thank you.